So I was asked by a colleague about basic programming exercises and looking at the sort of classic, block cutouts of program areas, and if there would be a way to make an algorithm that would help somebody get their head around the quantity of area they have in a program. So I did a really simple exercise, and I'm going to show you the code that I used to do it. Firstly, I've got some plugins on this. Nate Miller's Lunchbox. I think I used one of the components. Scott Overall Sasquatch. He's got a remove last item that I just, it's worth the price of admission. Group Nest by Ali Torabi, which is a really good like packing tool. And then Mark Sipes' bifocals tool, which is this little guy up here that's really nice for videos like these because it actually shows you these little tags on the components that just somebody set to the pictorial version of them. It helps you tell as a viewer of this video what you're looking at. So to get on it, the first thing I did was, and this is I think one of the Lunchbox components. If I hit Control Alt and left click, it'll bring me over to Lunchbox and show me where that is. So this is like an Excel, their legacy Excel reader tool. So if you have an open Excel file, it'll actually go to the column, go to the rows, start and end that you specify, and grab a bunch of data for you. And you can plug that directly into your code if you want, or you can just like grab it from the Excel file and paste it into one of these guys to get going. So what I have here is, I'm going to turn off preview. I've got a list of area sizes, program areas. And what I'm going to do is take that list and firstly sort them. You can see they're sort of randomly arranged by size. So I'm going to sort them by size, and it does that from smallest to largest. I'm going to flip it with a reverse list tool. And I'm going to take that and take its square root, because what I really want to do is get a box that represents each one of those pieces. So I take its square root and I use the square root to make a rectangle of each. And then I did some math where I did a height to width factor. I took that factor and did a square root to make it work properly mathematically. And you can actually do this. So, if I want a 2.6 to 1 ratio of height to width, I can do that. And then I took those rectangles and created a series of numbers with a spacing plugged into it so that I could I could do some mass addition, add up those numbers, and then move all these guys out into space with a little bit of spacing in between it. So if I back up, I can take this guy and kind of spread them out if I so like, or I can come back in and mess around with my height to width factor if I so like. I made the bottom of this a 1-to-1 factor, so it always returns to a square when I toggle it back. And then I took that and I grabbed the areas and put them in tags. And then the end result is you see you've got all the squares representing your program area with those tags. So then what I wanted to do was just do a really, really quick packing exercise. And this is where Group Nest comes in really well. That's this big old component right here. I'm going to take these guys and turn them on. Whoops. Has to think a little bit. And I kind of did some coding, just make it move off the palette up to the top a little bit. So what this guy does is going to take all our guys and put them into a box of a specified width and length. So again, I just came in and I actually took all the area values that I had. I took their square root and put them all together to make like a mega box they might fit in. Now, of course, they're not going to fit perfectly because they're not all the same size. So I did a little factor to allow me to make the box, its width and length, a little bit bigger to make them all fit, because the packing exercise, if I make the box too small, it'll start creating a second box for them, which is not really visible in this. But if you just do this in either direction, it'll rethink about how they pack. And I thought this was pretty cool because all I have to do is take all of the boxes that I've output and take all the labels that I have and put those items into this, specifying a length and width. And there are a few things you can do, like if you want to start rotating, if you have odd shapes. In this case, because it's such a simple programming exercise, I just want to get a grip on, like, at a single level, what does all this stuff take up? And the biggest elements, if you put them adjacent to one another, what happens to them? This tool doesn't really deal with adjacency, but it does sort of give you a sort of degree of what might happen if you start fooling around with proportions. I can make this guy probably shorter, and it's telling me something like, there's like kind of upset limit. If these were like big, I had 5 gymnasiums and a bunch of little offices, they'd probably tuck the offices into here. So I thought this was a kind of an interesting, very condensed code. It's got some heavy hitter stuff like this in it that helps you get to the bottom line in terms of packing. But then all you have to do is actually go in and give it the elements that you want. And again, you can do that just by like coming into here and cutting and pasting in numerous areas. And there's other stuff you can do too. You can come in and you can color code these if you want to make a printout on a sheet, or space them according to how you might want to laser cut these out of little cardboard or plexiglass. But it has a kind of brief moment in time, like right at the beginning of a project, where it might give you kind of grip on how much stuff you're dealing with. So that's it, and thanks for watching.